Okay, let's try this again. Share screen. I'm so excited that I just jumped the gun, didn't start recording. Sorry. So let's go back a page. Oh, it won't let me. This. Okay, let's try this now. So as I was saying, the VPN connects two portions of a private network, and the calling router authenticates itself to the answering router, the server. And the authentication happens either at the server. There could be users locally put on the server itself, or it could be with a certificate or a authentication server such as Active Directory or LDAP. So that would then be tied in. So it would check to see if you're authenticated against the network you're trying to get to and allow you to get in. So there's three types of site-to-sites, PPTP, L2TP, and IKE version 2. PPTP stands for point-to-point tunneling protocol, and layer 2 tunneling protocol, and then IKE, Internet Key Exchange version 2. And they can be persistent or on-demand, like I said, a nailed-up or on-demand VPN. And then, of course, you can control the traffic using dial filters or dial-out filters, ACLs. So, just reading the chat here real quick. SSTP, I'm not sure what SSTP is. I'm only familiar with what they've got here. Actually, they do have SSTP listed right here. You're just not waiting long enough for our slide deck here. So anyway, so we have point-to-point tunneling protocol. It's okay, but it's not, it's easily decrypted, and it doesn't provide for authentication very much. L2TP uses certificates and pre-shared keys, which is better than point-to-point tunneling protocol, but it's not the best. So there's better ones available. SSTP uses SSL, which is much better authentication, encryption. IKE version 2, that's the big one. That's what everybody normally uses. It uses the latest IPsec encryption algorithms. You can do AES 256, that type of thing. So it's very, very secure. All right, so then there's different authentication options that you can do. When you give your username and password out to the internet, it needs to be encrypted. So not just your actual data that goes through, but your authentication needs to be encrypted as well. So there's different methods of doing that. You can do PAP or CHAP or MS-CHAP or EAP. And these go through the different security levels, weakest to most secure. And basically, they're just different methods of using different hashing techniques, MD5, so which has actually been broken. So you probably don't want to use CHAP or PAP. MS-CHAP version 2, I think still is okay. EAP is definitely the way to go, though, if you can swing it. So, and those are options that you pick inside your actual device. So it's in a Palo Alto, there's hundreds of different authentication and encryption options available for them. So this is the VPN Reconnect. Apparently it uses a it automatically reconnects your VPN for you, so it provides a seamless and consistent VPN connectivity. Uses IKE version 2 and automatically reestablishes VPN connections. So So yeah, it's makes it so it's easy and seamless. The examples I've got here are the old way of doing things, and so yeah, it takes a bit for the tunnels to come up and everything. So you'll see it's interesting. Now apparently there's a feature that Microsoft offers called an App Trigger Vpn, and it just allows you to click on an app and it will automatically launch a VPN tunnel to where it's trying to go to use that app. So like a cloud-based Word document or something like that, it will automatically use a VPN to transfer everything. So you can use a VPN get started wizard. See, this deck has a lot of information in it for doing a lab, and we're not going to be doing this lab, so you don't have to really pay attention too much to some of these, like using a get started wizard or remote access management console. But definitely there's some good information here, because we have the server configuration uses two network interfaces, a public and a private. In our case, at least what I'm going to show you, the VPN server is actually your router. And so, yeah, it will have more than one network interface on it, public and private. And then you can do a pool of addresses so that you can allocate for clients. Or you can also do, if it's a nailed up, then it would just be, you wouldn't need the pool. And then authentication provider, again, you can either do a local, which is actual users and put on the router, or you can do authentication provider like Active Directory or Radius to authenticate users. And of course, you have DHCP relay agent considerations to get into if you're going to do DHCP. And to configure, you might want to think about packet filters and different ports and services. So you can use ACLs to filter your traffic and your ports and allow what type of traffic you want to go through. For example, you don't necessarily want to have all the users' traffic run through your network. So there you can set up what they call split tunneling, which says, okay, only certain stuff goes over to the through the VPN. The rest of it is normal web traffic. And so you can set that up in the client so that it only goes to certain servers on your network or on the main network, or certain subnets. You know, you can set it up for however you want. So it's called split tunneling. And then of course you can configure all of this using that. So you can do different logging levels and VPN ports, and you can do Active Directory. And of course you can increase your security and use the Reconnect. So again, we have this is a deck of things for different demonstrations. So it's mainly just information on requirements for IKE version 2, SSTP. So apparently there's an administration kit, and you can distribute CMAC profiles to client computers. So the server can actually modify the client computers using these CMAC profiles. Palo Alto, which was what we use here on campus, they have something similar. We use a Globalprotect VPN client. And I'd show it one to you, but my VPN doesn't work on my phone down here in the basement. I don't have any cell service, so but if I had cell service, it works quite well. So anyways, so can install their client, and you can distribute a VPN profile. And then the different virtual machines they want you to do. So what am I? Okay, yeah, we're getting close to the end here. So yeah, this is the lab scenario I was talking about them doing. And then you configured a VPN server to assign IP4 addresses, DHCP, configured a network policy, all that type of thing. So, and of course, the best practices and all that. So that's pretty much it for the slides here. But as far as the other stuff goes, so I've created some stuff in Packet Tracer that is a lot of fun, interesting stuff. So what we have here, we have the ISP router. We're in Packet Tracer, it's really hard to model the internet. So in this case, it's just one router is our internet. But for our purposes, it works great. We have a remote office router and a main office router, and then a couple PCs hooked up to switches on each. And so if you look at the CLI of the internet, you can see that we have two interfaces set to 209.165.100.2 and 209.165.200.2. And so that's providing network to two different places. But what you don't see on here is any sort of routing information in here. There's nothing. All it is just these two addresses assigned to these two interfaces. That's it. So how are we able to talk from this PC over to this PC at 192.168.3.10? We came from 192.168.1.10. So how does that work? Well, the way it works is it actually uses VPN to transverse across this router without this router knowing anything about it. So basically, we have created our own tunnel that goes directly from here to here. And it's a nailed up connection. So it's on all the time. This PC and this PC can talk to these two PCs or servers or whatever is over on this network anytime they want, any place. They just have to connect to the switch and get a good address, and boom, they're on the other office network there. And that's the benefits of having a nailed up connection. It's on all the time. So anyways, so let's take a look at how that's done inside the routers itself. So there's a secret to it. There's secret sauce. But you have to use certain routers in Packet Tracer. First off, there's a 1941 router. You got to use that one. There is another model which we'll see in the other example I've got that will also do it. But for this purpose here, the 1941 is what we've got here. So license information file here, we have boot module C1900 technology package security K9. So the security K9 is what is different about this router than the normal ones. And what this does is this allows, so when Cisco has firmware images for all of their devices, they come pre-packaged with all of the features available for the router, and you pay a license fee to enable certain features to be enabled on it. So in other words, it comes with everything, but in order to turn it on, you have to pay a fee. So I turn this on. However, Cisco is nice enough that they have a trial period. So if I had this router on, say, I think it's 90 days, if I had it turned on for 90 days, then I would have to pay a fee in order to keep this, this security license going. So, but it's packet tracer, so it's easy enough just to spin up another router if I had something running that long. So, and just to verify, you can do a show license feature, I think it is. Yep. And so the IP base is what normally comes on the routers, and this one actually doesn't have it enabled. Well, it is enabled, but the security K9 is yes, 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 and yes to evaluation here. So it's an evaluation version, whereas the other one's not, and it's enabled. So that's the secret sauce there. And then in addition to that, there's a whole bunch of configuration to do on here. And I don't expect you guys to know everything on here, because it did take me a good 20-30 minutes to get everything typed in. I actually used a tutorial to find everything on here. But basically, you have to create a ISA KMP policy with different encryption options. This one's doing AES 256 with a pre-shared key using a Diffie-Hellman group 5. So AES is an encryption algorithm, which that means 256 bits of that algorithm. Diffie-Hellman is a way of exchanging keys without actually giving you the key. It's kind of strange how it works, but basically you have a public key and a private key, and you can share your public key, and you can then exchange keys with each other, and the public key will decrypt into the private key. So again, it's kind of weird how it works, but yeah, it's some very smart guys named Diffie and Hellman came up with this scheme, and it's very ingenious. So anyways, so now you want to give a key here, an ISA KMP key, and then I've named it secret key, to this address here, which is our peer address. So 100.1, so 200.1 is where we're trying to give it to. So that we're doing a key exchange with this other router. And then we have to set up what's called a transform set, and we called it remote domain. Again, we're using AES 256 encryption, as well as SHA HMAC, which is another encryption algorithm. On top of that, you got to make a crypto map, which does all of these different peerings. And so you have to set in all of these different configurations in order to map the IPsec to the other, the router. And then once you do all that, you can then issue a command, crypto map IPsec -map. And the IPsec map is just a name. You can name it whatever you want. So for example, if I go in here into the interface and I say no crypto map IPsec map, now it's turned off, and if I go to my client, what I was being able to ping before, I'm not able to ping now. So it's down now because I've turned it off. But I just was trying to show you that yes, there is, it will not work because there is no routing enabled on this internet router. So the only way it was working is by encrypting our traffic to go across it. So so what I can do now is I can go back and I can re-enable it. And this is where the fun starts, because it takes a few minutes to come back up. Oh, there it goes. Actually came up faster than I thought it would. it took like about 6 timeouts before it finally came up last time when I first put it in. So once you've got it connected and once you've got some traffic flowing, you can actually issue a show crypto command, crypto IPsec, and then SA is the end of the command. And it will show you that this is your local network. This is your remote network. So this is what you're encrypting it to. Your current peer, that's who you're connecting to, 200.1. And then here it shows that encaps 3, encrypts 3. So in other words, it encapsulated 3 packets of information coming from this computer with the IKE information. And then it encrypted those same packets so that it then could send it to the other side without it being broken into. And then on the return, because that's a ping packet that I sent, they send it back to us. We decancapsulated 3 packets and we decrypted 3 packets. So it basically just shows you that, yes, indeed, we're passing traffic and we're decrypting and encrypting traffic, and where to and who it came from, that type of thing. So yeah, that's pretty cool. I thought that was interesting. You got any questions about that before I move on to the next one? No? All right.
So I don't know if you're, are other people, are you cutting off for other people or is it me?
Uh-oh, I can't, you just broke up.
Yeah, I
Peter,
feel
you
that
there?
too.
Okay.
Can you hear me okay?
So
There we go, that's better. Okay, so now I'm recording again. All right, so let's try this again. So where did I leave off, or what did people miss? Did you guys see me going through the configuration?
So we went through this, but you were starting to cut out a little bit.
Okay.
And I think we saw it, but we can go through it again a little bit.
Okay.
The question is
And yeah, I asked for some
remove the
questions.
window, that window, so you can see your diagram there, your logical diagram in Packet Tracer. And
Sure.
you've got the blue to the red to the fuchsia or the fluorescent green.
Right.
So that right now you can ping from the 1941 main office to the 1941 remote office, right?
Correct.
Because those are connected interfaces. Now, if
they are encrypted because there's no router on this router. So that otherwise they would not be able to do it.
There's no route.
Yep.
There's no default route or anything.
Not on this router. There is a default route, a static route on this one. You have to put that in order for it to work. And that's, where'd it go? Right here. IP route 0.0.0.0 space 0.0.0.0, and then out to the default. It's basically a default gateway for that router.
And do you have to have that on both sides?
Yeah, so you have to have a default route on this one and a default route on this one, but there's no routing on this router here.
But you could have had routing.
Oh yeah.
To still set up the VPN.
Yeah, it's just it's better for demonstration if you don't have it there, because that way if you turn off the encryption, you definitely, it won't route at all. So if you turn on the encryption, then it routes it through.
Yeah, by default that wouldn't be the case in a router. You would have dynamic routing and you would have all the routes around it.
Correct.
But you did that with a default route, just say, if I don't know what to do, send it out this interface.
Right.
That way, when your tunnel when you stop the tunnel, pings don't work. I see what you're saying. Yeah.
Correct. Yep. It's just a way of simulating the internet, because that's not really the way it works, you know, but for demonstration purposes, it's good enough to show you what the VPN does. Now, any other questions? Anybody else besides the other instructor in the class? No? All right. I guess we'll move on. So go to my other one here. I've got a client server model. So we did a nailed up one that's always on, but then we also have a client server. Let me zoom out just a smidge so everybody can see it. All right, so in this case, we have a home network, ISP, same type of thing with the ISP, and then the main office network. So we'll have to wait for a minute here for the switches to catch up with us, because right now they're amber because they're doing their spanning tree.
You can hit the double arrow key in the bottom left and increase the time by a couple minutes or something, and then the simulator will just automatically then enable them all real quick.
There we go.
Yeah.
So we've got basically the same situation, except this router, it doesn't have the same configuration. So it's just got the two interfaces. It doesn't have the fancy license on it. It's just a normal router. And well, this particular one is a remake from last time. So it's got a whole bunch of interfaces to it, but you can just see it's got a NAT configuration so that it will do an inside to outside NATing, just like your home router does at home. And then a default route as well somewhere in here. Yeah, the IP route 000. And then again, that's to just to simulate a real one, how it really works. But this router here is basically just your normal router. It's nothing fancy to it at all. There's no extra encryption or anything going on. The encryption actually goes on in the client here. So what you do is you click on the client, go to desktop, click on VPN. Oh yeah, that's right. Now we got to type in a group name, a group key, a host IP, username and password, and then you can click connect. And so we're going to get all that information from inside this other router. And by the way, I posted both of these packet tracer files to Moodle, so if you want to play around with them, you can. Let me get back to here. All right, so now we can see both of them at the same time. So this one definitely have to have the license for the Security Net K9 package. Got to have that. It's got the same type of policy for ISA camp that the other one had. But you've got now a VPN group pool that you have to have in here, and it's one of the configurations. There we go, that we put in here. So the VPN group is called VPN group, and you got to use the capitalization. It matters. The group key is Cisco VPN group, and then the host IP is.
And again, these are groups that you made up, right?
Oh yeah, yeah.
Yeah, they're not.
This is all something I put in.
They're actual. Peter made these up so you could make them, you know, Mark's VPN group or something. Right. Yeah.
Yep. And then here we had it set up for a local authentication, so it only goes by users that are installed on the router itself. So in this case, we only got one. It's called Cisco, and it's got an encrypted key here, but I'll show you the password. It's a secret password. Cisco. And then Cisco @123. Oh, it doesn't display it. Yeah. Anyway, so it's a Cisco with the @ and then 123. And then you click connect, and it will fail the first 2 or 3 times because it's packet tracer, and eventually it'll connect. And again, this is the kind of the old way of doing things. Yeah, see it timed out. New style of things. You've got an app, usually on your phone or on your computer. In this case, it's Globalprotect. I don't know if you can see that. And you just click connect, and it will go and connect out to the internet. I don't have any internet service down here, so it's not going to work. But yeah, it's very simple.
Go into your configuration though for that. So you download the app on your phone, or you download the app on your laptop, and then you've got a configuration, some configuration settings.
Right.
That what you were doing right here with Packet Tracer, you had to do with Palo Alto's VPN, right?
Although the client side, it really doesn't have much to it. You just type in the address, and then your username and password for you just use vpn.scmartin.edu, and then you type in your username and password for your email address, and it will connect if you're part of the VPN group. So if you're a student here, you probably don't have it. Add username or password. Well, that time it actually worked. Cisco at 123. There we go. VPN is now connected. So now I can go into command prompt and ping 192.168.1.10, I think it is. 1.2. All right, and that's going to make a monkey out of me. There it goes. I just had to wait too long.
We're waiting with bated breath here. Oh, please work, please work.
Yeah, exactly.
One point to note for everybody, this IP address that he's using, 192.168.1.2, in this case, it all works because he's in Packet Tracer, but in reality, that would still work even on the internet.
Yep.
Because a private net, that's a private Class C address, a subnet, which would be blocked by every router on the internet because those do not route publicly. But even on the actual internet, this would still work because the tunnel is tunneling and creating from your home through, and that is the IP address from your home into your main office. And so it's connecting using that, even a non-routable or publicly non-routable IP address range.
Yep, and that's what we've got modeled here. We have a 10.0.0 address for this network, and we have 192.168.1 network over here, and then the internets have more publicly routable ones like 1.1.1 and 2.2.2. So yes, Mark is exactly right. It will still work even though you're using private ranges and you're going across the internet. So it's one way of using a private range on the internet, so without having to do NAT. Although in this case we do have NAT configured on one of the routers. But still.
In this scenario, or you mean at the school?
In this scenario, yeah, this router here has a NAT policy attached to it. This one does not.
But that was not necessary though, right?
You know, I don't know. I don't think it is. I don't think it's necessary. I think it was necessary for the ping because, like I said, it was. I took this off a tutorial, and they wanted you to be able to ping this interface here. And in order to do that, you had to have a NAT. Actually, now that I think about it, yeah, because it's packet tracer, you don't need to do a NAT, but it's configured in there anyways. So.
That would be a more realistic guess. That is true. If you had a router that was on the internet, 1.1.1 on that one, yes, you would need to have a publicly routable IP address. Yeah.
Well, shoot, I went through that way too fast. So let's take a look at the config on this again, because I didn't really go through this very well. So in this case, because we're using a client, we have to use a pool of addresses in this VPN group. And it's got a key. So you have to configure this key. In this case, it's called Cisco VPN group, but you can name it whatever you want. And that's a secret, so that you have to share that with your user beforehand. That's why it's called a pre-shared key. And then so they obviously will have this key in order to decrypt the traffic properly. And then you have to set up a transform set, and then a VPN set is what we've called it. And it uses AES encryption and SHA HMAC encryption as well. And then you have to have a dynamic map, they call it. In other words, before when we had a map, it was statically assigned. This one is dynamically assigned because it's an on-demand system. And so it will create the map in its own software as it goes. So that's also a reason why it takes longer in Packet Tracer here, because they're just not as powerful as a normal router is. So, and then you have to have a reverse route so that it knows where to send the traffic back to you. So it's like a routing protocol basically inside this map that they have, a dynamic mapping of users to IPs on the remote side. And then we have another map called static map, and then we can authenticate clients using VPN user, which VPN user we defined up here to be a local user, somewhere on here. Anyway, so it's a local, it's the part of a list. Maybe it's further down. Yeah, here we go. Local pool, VPN pool. So this is something else you have to configure on here. This is the IP addresses of the different client computers. And that's, so you have authentication and authorization. So authentication is just saying, yes, I have this user in my database, and yes, he gave the proper password. Authorization means, okay, he's allowed to get this certain group of addresses that we've got here. So it's like an access list. So it's able to get to this VPN pool, which then gives him a certain address. And so, yeah. And then, of course, everything's dynamic. So you use dynamic VPN. So once you have all that map created, then you apply that to an interface with one command called crypto map static map. And this name is just something we made up. We can make it whatever we want it to make. And again, we don't expect you to be able to recreate this because it's quite a bit of configuration involved with all this. But next week we are going to be, your lab is going to be on making a VPN out to one of your AWS servers that you hopefully created last week or on Tuesday.
Yeah, so in this scenario, you are doing all of the setup through a Cisco router. This is how Cisco does it.
You're right.
And the encryption is built into the Cisco router, and it's effectively the like certificate authority, basically. It's generating the encryption. It's encrypting this tunnel, and through the ISP, through the network, and
Yep.
over to, like, from home to the main office.
Yeah, and
Now,
Palo Alto does the same thing.
in the case of Amazon Web Services, we're going to use OpenVPN, which is a software product, which is a VPN server, and it will do the configuration of creating a remote access connection to your laptop and phone, and it will be a real VPN. I mean, it's something that you will be able to use and you don't need to pay for it. But you also have to generate, it's a little bit different, the configuration in this, because you'll have to generate a certificate authority from a certificate authority that you utilize, and then add that into the VPN server. That generates these configuration files, and it's like a pre-shared secret, like what Peter just said. Then you got to take that file and you've got to copy it to your laptop, or you've got to copy it to your phone to get those two to actually work, because that file has the hash or the encryption, the encrypted portion of that private key or public key, and that'll allow it to connect to the VPN server in an encrypted fashion. So one thing I wanted to add too, we talk about encryption, like we go to a website and it's HTTPS, port 443. It's using encryption. But what is that really encrypting? It's encrypting the data in the packet, okay? The actual data in each packet is encrypted, but not the header, not the footer of the packet. So if someone intersects that traffic, it sees the source and destination IP address, source and destination MAC, and so forth. It's part of the header, knows what type of packet it is, but it cannot see the data segment, okay, inside that packet as it's being sent. But this is different. This is encrypting the entire packet, the entire communication stream is tunneled, so no one knows where it came from, where it's going. So the entire packet, header included, is all encrypted in this tunnel. So there's two components here.
Yeah, so that way even the source and destination address are encrypted on it. So basically, the way it works is the router or the encrypting authority has a link going to the other destination, and it will put its own source as the source rather than your computer as the source. So it will obfuscate you for your
location
in the traffic there, in the source and destination address on the packet, each packet. So yeah, it's completely encrypted.
Yeah. So if you're wondering how is tunneling different from just secure traffic, that's what it is. So you can securely communicate to, like Amazon. You can buy a book on Amazon or something, and what you sent, your password, your credit card, whatever you're doing, is encrypted, but that's the data packet portion of the packet, okay? Your payload, and not the rest of the header and footer. So that's the difference here, is that it's still encrypted, but now the entire communication stream is encrypted. So tunneling is a more secure way to connect. There is overhead, so there's some additional overhead. So that, depending on processing and so forth, there could be another delay. But what is that doing? People don't know where you're going. Comcast, if they want to track where you go and sell that to advertisers, they can't find out where you're going. Okay.
Yep. No. And it's I had a thought. I can't remember what I was about to say.
Well, what about a VPN like from on campus, Peter? Let's say you created a VPN and you were VPNing out through St. Martin's out to somewhere on the internet.
Okay, so like I said with the Palo Alto, you can decrypt traffic using the Palo Alto, but that's normal web traffic. If somebody were to fire up a VPN, there's nothing I could do for it. No.
So you're blocked even from Peter when you're
Yep.
on.
Yep.
If you didn't put that together, but not that Peter cares, but the point being though is that it is more secure, and that a Palo Alto can unencrypt, look at the data, and then re-encrypt and say, oh, you're going to wherever, you're going to this website and this kind of traffic, right?
Right. Yeah.
If you didn't know that, if you thought your traffic was secure because you're HTTPS to a website, it's not exactly secure.
Not exactly. So yeah, when it comes across the firewall, I can see that you went to a certain site, and I may not be able to see all the encrypted data that's on it, but I can definitely tell that you went to Amazon or wherever. And so yeah, and maybe that's allowed and maybe that's not. So I could block the traffic or allow it, depending on where it's going. But if you fire up a VPN, there's nothing I can do about it. I can't see anything with it. It's just numbers. That's all it is.
But as Peter showed in those slides, depending on the type of VPN, you don't want to do point-to-point tunneling protocol. That's an old, outdated. That was one of the first. But these other secure socket tunneling protocol or IKE version 2, that's the most secure, IKE version 2.
Yep.
When you open those up, then you have specific ports that have to be open as well to use those. Now, it may be that not all those ports are open in our firewall at St. Martin's. So it's possible that you would not be able to establish maybe an IKE version 2 tunnel if those weren't open. But we always have to have 443 open. So secure socket tunneling protocol can always work because, well, 443 is for just secure web traffic. So it has to be open.
Right.
So I was the router guy at a previous company, but I was not the security guy. So then I said, I need these ports open. And security guy says, no, which they always say no. Then, you're not totally lost with VPN. If you're like, oh, if you look at IKE version 2, what are all the ports? There's several UDP ports that have to be open. Okay, but there's only one port that has to be open with secure protocol.
Yeah, that was in the PowerPoint. There was
Yeah.
a whole bunch of different ports that were opened up with it.
Hey Peter, I got 2 questions real quick.
Sure.
So first of all, if you are allowed to use VPN on the intranet, do you have to put that configured on your DHCP server in your network or in your the whole net, or is it automatically assigned, or how does that work?
Okay, I'm trying to envision what you're trying to ask me. So you're going to try to put a VPN on the intranet, and the endpoint is inside both points are inside the intranet?
No. So one is outside.
Okay.
Like on this diagram, you're trying to send it from PC0 to PC1 down there.
Yeah.
And let's say you have a DHCP server on main network, and you're connecting VPN from home to the main.
Oh, I see what you're saying.
And
yes.
So on the DHCP server, do you have to create another net, on
Yes.
DHCP that for the VPN?
Right. So in this particular situation, where the client computer is getting an address from here, basically this router is acting as a DHCP server and hands this computer a new address.
Oh, okay. So you don't have to manually set anything on your DHCP
Correct.
server since the router is doing that.
Right.
Okay.
Or in our case here on campus, well, actually that's true too. The Palo Alto is going to hand you an address. Um,
Oh, the
like
application
when you do,
firewall.
yeah, when you do Globalprotect,
Yeah,
the Globalprotect will hand you an address. So
I
I had
see.
to set that up in the Palo Alto firewall.
Yeah, so maybe explain, Peter. So you've already got an address, right? On
Right.
both sides. Why do you need another address for this tunnel?
Well, in order to be on this network, you have to appear over here to be on this network. So you need an address in this range in order to communicate properly. So um, this router is going to hand you an address in the 192.168 range in order for you to be able to route through this.
Because if it didn't give you that, and then your packets come through the tunnel and you come in as someone on the 10 net,
Right.
then
It
it's
doesn't know
like
what to do. Doesn't know how
then
to
they're
route
like,
that.
well, how did you get in? Because you're a 10 net person and that's a different subnet. So then you can't actually talk to the people on that subnet.
Right. Although I think the actual configuration in this one, it routes it because it does give 10.0.50 addresses, I think. But yes, what you're saying is the way Palo Alto is set up, whereas because it'll give you a 10 dot address, which is what we have here on campus.
Okay.
But
And my second question is actually to see if you can
yeah,
provide an instruction like we had for the lab 2 for setting up this packet tracer and doing all the thing. Can you provide us a instruction to set this up? Like we'll worry about the CLA command side, so we can learn or try to do hands-on.
yeah. Well, when we're doing the AWS lab, then yes, I think Mark is going to go over how to do most of that.
Yeah,
Great.
so Peter can throw up the tutorial he took and his packet files, PKT files, so you can see this configuration on Moodle. But when
Right.
we actually set this up for real, like on AWS, you're going to have a real virtual server with Ubuntu running, and you're going to actually install, apt-get OpenVPN and install the software and install the certificate authority and then configure those so that they work. And then of course you'll download and install the client on your laptop and the little like an iPhone app on your iPhone. Then it's different. It has a setup and configuration instructions specifically for OpenVPN. And so you're actually doing the configuration, really you're modifying the OpenVPN config files to your specific situation to get it working, but it's a step-by-step. But the concept is the same here, although instead of having a router being your VPN server, it's an actual separate VPN server, a VM, a virtual machine
Right.
running OpenVPN. Yeah, is the software. So the concepts are the same, but the configuration steps are different. But you can do it. He's just showed you now how Cisco does it. Then we're going to show you how just a regular Linux VPN server would be set up.
Yep. Because the trend in networking today is that a lot of actual networking functions are being done by server-based type things like firewalls or VPN. When you get into more computationally intensive things, it's better to put it on an actual server. So yeah, that's kind of the way things are going. Same thing with network automation. You use a server in order to automate all your network devices. So yeah, that's kind of the way things are going. So that's why we're showing you can do it on a device and have the device use its encrypted VPN, or you can do a server based. And so of course the Cisco one's going to cost you money because they want to make money, and then the Open VPN is going to be more open source, free, but of course you've got to set it up. So that makes
Now,
sense.
in the case of the Palo Alto firewall, the Palo Alto device is separate from our router. So it's separate from the Cisco router, and it's doing the firewall and it's doing the VPN portion separately. So that's an appliance in our data center at St. Martin's, right?
Yep. And the VPN portion, the Globalprotect portion, is a separate license that we have to purchase. We have to renew it every year. But it's very, very effective and works very well as long as you have cell service. So,
well, I could show the VPN, the Palo Alto VPN, my actual VPN, to the school.
okay,
If you wanted.
sure. You want to share your screen? I'll stop sharing mine.
Okay, let's minimize that and share my screen. Okay, so I'm sharing this screen here, and I'll go in and type in. Okay, minimize you guys. VPN. Now there can be. I've done this two ways. If I go into my VPN settings, okay, I did it first download the Palo Alto VPN client. I installed the client, and then I went into the client and put in my information, okay? So that's one way to do it. But there is also a built-in VPN. If you just type in VPN there, okay, it'll go to this, and you can add a new VPN connection. And so this service within the networking component of your operating system, like Windows, you can put in your VPN provider. Okay, in this case, you've got a Windows built in or Globalprotect. Why Globalprotect pops up is I still have to have the Globalprotect client. Even though I'm not going into the client through their interface, I still have to install the Globalprotect client through the Microsoft Store, and then I put in my connection name. Maybe I call it St. Martin's or something, and then I put the name. So if I look at what I've done, okay, which is this one here, and do advanced options, edit, okay, this is what I had to put in. I created SMU as my connection name, and the server name was vpn.stmartin.edu. So very simple. Peter created this, and it's in DNS as this and resolves to the firewall. And so then you you do put in your password, and it remembers your password. And so anytime I go to type in.
So all of the key exchange and everything is all taken care of for you automatically with the Globalprotect. So all you have to do is put in your username and password and the server, so which is vpn.stmartin.edu.
So once if I do connect, then that's it. Just verifies your connection, completing the connection, and now I'm connected. Okay, now, but if I go to a command prompt and I look at then the VPN should have given me that information. So here is this. Is this right here, Peter?
Yeah, that's the PPP adapter. Yep.
And that's the IP address that you gave me.
That I gave it. Yep.
And so it gave me a 10.252.0.125, and that's Peter determined I'm going to use this subnet for the VPN at St. Martin's, and so he determined that and gave me an IP address from that, and that connects me in to as if I was just right at my desk at St. Martin's, and then from there, then if I've got mapped network drives, if I want to go to the share, if I want to go to internal resources or whatever, or look at files or share drives, those are accessible to me, whereas previously they would not be. Okay. But yeah, he gave me that. And so why it's called SMU, because I called it SMU. That was the name I created for my little VPN connector. So you've got lots of virtual connectors. Here's my wireless. See, this is my actual IP address right here. 192.168.50.1. Sorry, that's my router. Here it is. 192.168.50.161. So here's my IP address at my home, which is just a non-routable, but of course my wireless access point is my router, is my network address translation. So it translates it to a routable IP address. But when it creates this tunnel, then I have this is my IP address. When I come into the network, if Peter says, who is this person? And the IP address he's going to see is 10.252.0.125. That's my IP address.
Yep.
At St. Martin's.
Yeah, in the VPN for here at St. Martin's, that's to come in from outside from campus on used services here on campus, such as different servers. If you needed access to shared folders and things like that, that's what you'd use it for. So there's a couple people asking about, is this available for students? And no, it's not the same as like a NordVPN, which is where you're using a VPN connection to go out to someplace outside of the country to obfuscate who you are. So
yeah,
that's not what this is for.
The one that we're going to create with OpenVPN is, I think, the VPN that you want to have. This VPN, right. If you were given one, you would be able to VPN into St. Martin's, but that just is this as if you were at St. Martin's to begin with. So right. From home, you could get into St. Martin's, and you could get to resources, internal resources at St. Martin's. But typically it's just like this way I can do yep. Things that I say I needed some type of file or something on St. Martin's network. But that's
if you're wondering why Mark's connection didn't drop out when he got that new address, it's because we use a split tunnel here. So all of his internet access traffic, such as the Zoom call that we're on right now, is going out normally, but anything that he's trying to access on campus goes through the tunnel.
Yeah.
Does that make sense?
And in fact, without that split tunnel, had I created this VPN, then my traffic would all go through, even this call with Zoom would now be routed through the tunnel, everything into St. Martin's, and then it would go out St. Martin's internet feed out to the world, to Zoom, and you would right. See the streaming service. So it'd redirect all my traffic through the tunnel without this split.
Right.
Yeah.
Yeah, and that would probably drop your connection to Zoom if you're trying to do it while you're doing a Zoom meeting. So
yeah, it would.
You'd have to reconnect.
Yeah. Yeah, exactly. So that's now VPN Reconnect is a feature where, let's say you were in some building and then you picked up your laptop and you walked to another building and then you open it up. Ike version 2 is the only tunneling protocol that you could use where it would automatically reconnect for you, your tunnel. The other ones, I've got to go back in, I've got to go into my VPN, I got to click connect again. I mean, no big deal, but that's just a manual process. And
So the reconnect will do it for you automatically.
yeah, it'll just automatically reconnect it.
Nice.
Yeah.
Yeah, with Palo Alto, there are actually 3 different options that we could have done. One of them is to have I can't remember what they're called, but there's an option where, like, if we were to hand out laptops to faculty and staff and that type of thing, we could put Globalprotect on them, and it would have a nailed up connection all the time with Globalprotect. So basically, your laptop is now your own VPN router. And but we didn't implement that because we don't give out laptops. And then there's an on-demand system, which is what we did deploy, which is where you manually connect to it. And then there's an auto connect one, which I wasn't very familiar with and didn't really want to chance of it not working. So we've stuck with the on-demand system. It seems to work pretty well.
So this VPNs have become so utilized all the time because they're secure. Like Peter said, you can they can be nailed up, so they can always be between like a corporate site and a sales site or something, and you can use that as your secure communication instead of a separate leased line. And if you have a high bandwidth business connection to the internet, then you could do both internet traffic and VPN traffic to corporate headquarters and not have the added expense of a separate dedicated WAN link or wide area network connection.
Yep.
There is another element of this VPN that Microsoft has tried to create a better VPN than VPN. And it's called direct access. Have you heard of this, Peter?
No, I haven't.
Okay, so they tried to take all the things that were limitations in VPN and they tried to improve upon it, but it's only, of course, for Windows products. It's pretty much operating systems 8, 8.1, and Windows 10 for desktop. And then it started with 2008, but that's end of life. So 2012 server, 2016, 2019 Windows Server, those versions you can use what's called direct access. So some of the limitations with VPN are, I got to know if I'm at work or I'm at home. And if I'm at home, I manually start my VPN. So their direct access, they put in the files and the software into your operating system so that it checks for a network location server. And if it can find it, it says, oh, you're at work. You don't need a VPN. But if it can't find it, it says, oh, you're outside the firewall. And so it creates a VPN automatically for you. So it's like always on. You don't even know about it. Huh. And it's split tunnel. So it's traffic that needs to go to your corporate headquarters, it goes there. Traffic that does not need to go there doesn't go there. So that's another limitation of VPN. Typically all traffic goes through the VPN now. So it's smart that way. It's on. There's no turning it on off. It just automatically turns itself on when you're outside. So you don't even have to worry about it. And there's another thing where, let's say Peter did give out laptops to all the students and all the teachers. Well, if we used VPNs to get into our file server or whatever from outside, Peter cannot run a query on our laptops to say, hey, are you with the latest operating system? Do you have latest patches? He couldn't push out a patch to us. It's not two-way communication. There's some limitations with VPN traffic. He couldn't do some audit or inventory or something. That would not work. But direct access has that ability. You can push out patches. You can do inventory. You can do a lot of things that you can't do with a VPN. So there are some traffic limitations with a VPN that they overcame with this direct access. So those
provided you're on Windows.
Yeah, but it's just on Windows. VPN is a technology that's a standard, and it can be on Mac, Linux, Windows, whatever, but not direct access.
Interesting.
I actually have one more comment on that,
Sure.
if you don't mind. So there is some sort of security network, cybersecurity disadvantage of VPN that if you're using VPN and if hacker find out that it's VPN and attack the DDoS attack on that packet, then as soon as VPN turned off, then your true identity, which is public IP and all the information revealed momentarily. So there is a prevention is something called kill switch. So as soon as your VPN connection disconnect, it'll disconnect your real connection too. So your identity will not reveal. But if you're using VPN that you don't have kill switch, then there is a chance that they can find out your identity. So you gotta be mindful of that. If you're using like school or your work that you're not using public internet, then there's not a lot of thing to worry about. But if you're actually using VPN to do something outside, then you gotta be careful of that. Make sure the VPN has kill switch. Otherwise, your true identity will reveal so easily.
Yeah, so when Gary has created a VPN tunnel to North Korea to spy on them, he does not want his identity revealed momentarily if his VPN connection goes down.
Yeah, there you go.
Then they're going to track him down to his house.
Yep.
Yeah.
So yeah, the kill switch is really important when you're using outside, not for the work or school or something like that.
Yeah, that's good.
All right,
Good.
well, that's pretty much it for the class today. Any questions? Or you guys can take off.
Yeah, any questions, feel free to stay. Others, it's 2:20. You can drop off. That's the end of the class.
Right.
Peter.
I need a bell sound effect.